Okay, so in this very quick video, we're going to have a look at how the difference of energy for different types of EM radiation changes how it interacts with objects when it's absorbed. So here I've got the EM spectrum from gamma all the way down to radio waves. And if I'm looking at it in this order, as I travel along this way, what I'm doing is I am decreasing frequency, and I'm increasing wavelength. So gamma, X-ray and UV have got the shortest wavelengths and they've got the highest frequencies, whereas radio waves and microwaves have got the longest wavelengths and they've got the lowest frequencies. That means, very importantly, that as I travel from gamma to radio waves, I'm also decreasing energy, because energy is related to the frequency of the radiation. So these three, gamma, X-rays and UV light, are very high energy, whereas further down these are lower energy, and that causes them to be slightly less harmful, which is a good thing, but it means they can do different things. So we're going to have a look at two main brackets here, and that is these three to start with, and then also we're going to look at these two, infrared and microwaves. Gamma rays, X-rays and UV light are often grouped together because they are called ionizing. They are ionizing radiation. Now, ionizing radiation is just radiation that's got enough energy to knock an electron out of an atom. So if you have a photon of gamma, X or UV light coming along towards an atom like so, here's my atom by the way, I've got the nucleus with the protons and neutrons in, and then I've got the electrons orbiting in shells. If the radiation comes along and hits an electron, that electron can be knocked out of the atom so it no longer is part of the atom. Now that makes this atom into an ion because it has an unequal number of protons and electrons, and it also means it's pretty easy to be used up in chemical reactions. Now only these three can ionize because only these three have got a high enough energy to do that. Visible light isn't quite as high energy, therefore it can't ionize. What it can do is partake in chemical reactions such as photosynthesis. But as we go further down, another big group is infrared and microwaves, and these two are often called heating radiations. They have a heating effect. Now, if you have a photon of infrared or microwaves coming towards an atom, if it hits an electron, nothing's going to happen to that electron particularly. It's going to gain some energy, we'll talk about that in a moment, but it's not going to be knocked out. It's not going to change energy level. However, the atom itself will absorb that infrared or that microwave radiation, and because the atom is now more energetic, it means it has more energy and therefore it moves more. So as photons of either microwaves or infrared are absorbed by these atoms, it causes the atoms to start to move more because they have more energy. Think about if you drink an energy drink, you might get a bit twitchy, move around a little bit more. Now, atoms that are moving more, we say that they're vibrating more, because that's how atoms in a solid at least move. They can't move around, they're stuck in their place. If they're vibrating more, that means that they are hotter. So these are heating radiations because when they're absorbed by an atom, it causes the atom to vibrate more and therefore the object to heat up, because temperature is just a measure of how much kinetic energy an object has, and if something is vibrating more, it has more kinetic energy. And just very quickly, the final little section is radio waves and some high end of microwaves. They haven't got enough energy to even do this. So radio waves, they just cause oscillating electrical currents in wires, which is another video I'd recommend you go and have a look. That's all.